And so this is the alum panel. These are our awesome alums from MIT, MIC, and Harvard, MIC. And so I'm just going to let them introduce themselves.
Wait, we should get another chair.
What? Yeah, let's grab another chair. I didn't know if you wanted to be part of it. Sorry. Oh, that's awkward. Okay, this is a huge panel now. All right, yeah, so maybe, Michael, do you want to start? Introduce yourself?
Oh, okay. Hi, everyone. Can you guys hear me? So my name is Michael. I graduated MIT in 2017. I majored in 6-3. I lived in Next House. And right now, I'm a second-year PhD student at UC Berkeley.
Hi, I'm Bristy. I graduated in 2018, and then I did an internship in DeepMind, and now I'm working at a startup in Palo Alto.
I'm Surya. I graduated from MIT in 2017. I spent a year at Google Brain, and then now I'm at DeepMind doing research.
My name is Jeremy. I graduated from Harvard in 2015, and right now I work at Google Brain as a research sway.
Hi, my name is Sims. I graduated from MIT 2017, and right now since MIT, I've started a company in computer vision and AI that's tackling security challenges.
Hi everyone, my name is Hassan. I graduated from MIT in 2017, and for like around a year now, I've been CTO for Stellar Labs, applying AI to international development.
Hi everyone, my name is Ali. I graduated MIT in 2017, course 6-3, lived in student house. Right now I work in a small startup working with hardware in Palo Alto.
Hi, I'm Shraman. I graduated MIT in 2018, I guess, with my master's, and I'm right now an AI resident at Google on the perception team.
Hi, I'm Jackie. I graduated also with my master's in 2018. I just came back from kind of exploring education and entrepreneurship around the world, and I'll be starting at Facebook as a software engineer.
Cool. All right, so we have a few questions. Just gonna be kind of informal. It's nothing like super crazy. First one's a softball. So how do you pronounce machine intelligence community, the abbreviation? Is it Mike or MIC?
MIC.
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 All right, so you heard it here. So a more serious question is, what areas of machine intelligence are you personally excited about? Anyone wants to jump into that?
Okay, so I'll start. Probably my opinion will differ from most of the panelists because I guess my research is more from the academic setting and rather than the industry setting. So what has drawn me to machine intelligence is my own personal desire to understand myself. And I think that intelligence is a very essential part of who I am and what all humans are. And machine intelligence is basically just trying to express who we are in math and execute that in code. And I think that the formulating in this way helps me make connections between my own personal life and my own research. And that's those are the motivating things that make me excited about machine intelligence.
So for me, I'm more interested in machine learning stuff are being applied in the real world, but there are lots of safety issues and also interpretability issues. Yes, we know that these machines are smart, but how do we understand them? So my interests are more around safety and interpretability of machine learning. Yeah.
I'm really interested in agents that learn, and I envision agents one day that learn much like we do. that don't need many examples, that can learn and act robustly in the world, and act sort of like we do. I think like we're sort of a fascinating object of intelligence, and I would love to see that being computationally manifested. I think much like Michael said.
You can see this got deeply philosophical fairly quickly. Yeah, so I guess part of current machine learning research frontier that I'm interested in is meta learning and meta optimization, because I think that we as human beings are fascinating as an example of intelligence, but there are umpteen other examples of intelligence in our world, and then a space of possible minds that don't currently exist but could exist, that do information processing at levels that are inconceivable to us, which it would be wonderful to understand and to have teach us and to discover foundational sort of truths that are beyond our perceptions. Obviously, I am a creature that was, you know, sort of like born in this sort of environment that basically only takes in a few particular types of sensory perception. It's very limited and thinks at a very particular level about human-like things. So there's this want to get beyond us and our minds, and I think that understanding intelligence lets us do that.
Yeah, so one thing that fascinates me is how much data there is available just everywhere, and how much of that data isn't captured. So looking at machine intelligence as a way to capture and do something with that data is something that really interests me. So as an example, at Synapse, where I work, what we do is, you know, there's every day so many people go through airports, go through X-ray screening. None of that X-ray is captured anywhere. We're taking all of that data, aggregating it together, and building something where now you don't have to have a human that's screening. You can have an AI that screens much, much better in that environment. So just looking at all of the data that's available, I mean, in healthcare, in, you know, in whatever different fields there are, and being able to capture that is something that really interests me, and I think machine intelligence has a big role to kind of convert that data into useful things. And so as part of that, active learning, just generally semi-supervised learning and unsupervised learning is really interesting, because right now one of the bottlenecks is just labeling the data in these applications. Sort of incremental learning is also pretty interesting to me. So.
So one of the area that I guess hasn't been mentioned that I kind of got interested very recently is causal inference. So it's about how do you like learn cause from effects and like learn to reason about the world without necessarily having the data. So there's an area called counterfactual reasoning or counterfactual machine learning. I found that kind of very interesting because it's very close to like scientific modeling and enable to like build model of the world and reason about them and seeing, okay, I've, you know, have this experimental setup, what happened if I change this like parameter and things like that. So I kind of found that it's been a recent trend, actually a bit away from the data into more into the modeling of the world. So I got I found that interesting to see development in this area.
I think for me, an exciting part of machine learning is applying it to mobile platforms. So today we have a lot of really interesting research done on computer vision, for example, pose estimation or object detection. However, most of those models, they don't run well on our cell phones. So if we run them on cell phones, the cell phone will run out of battery. It won't be able to run it in time. And there's a lot of really interesting development in the area of mobile machine learning, which is basically using the hardware itself to accelerate the models, figuring out how to reduce the size of the models so that it doesn't take up too much space on our cell phones. And I think this is a very exciting area, which is also something that my startup is working on, so this is why I'm very interested in it.
Echoing some of the other thoughts that have already been said, I'm really interested in, I guess, a lot of the innovations that have
just recently come up in learning with unlabeled data. So we have so many different sources of data, and a lot of it is just in raw streams without any, I guess, like annotations. And people have been coming up with really cool ways. One specific example is in computer vision. People have found out how to just take unlabeled video data and learn things like 3D structure of objects, how to detect objects, and also things like depth and ego motion, all without labels. And I think this, as well as like these recent trends in active learning, like how do we keep on learning without having to, I guess, like learn from a fixed subset of the data that we can collect. I think these type of trends are really interesting. Yeah.
Just adding on to what everyone else said, like one thing that really interests me is the things that humans can do so intuitively, but machine learning algorithms right now fail to do. How can we kind of bridge this gap and like leverage what's really cool about things like deep learning, but also combine it with some more like robust methods. But one thing also that I've been thinking about recently is like, how do we, even though we can collect all the data in the world and like we can like manipulate people to give us data or like to improve their like, I don't know, recommendations or make products more personalized to them. Do people want that personalization? Are we collecting it in ethical ways? I mean, obviously, like, for instance, like Facebook and I think Google and other companies are like facing these issues, but I don't think there's been a lot of thought or discussion around kind of like how do we design our products and the values behind how we run businesses and research to give people the dignity of their data, like their data is something they should own, but how can we still use it to benefit society, benefit these people at the end of the day?
Yeah, so that's kind of a good segue into the next question, which is what areas do you see as like fundamental, and what foreseeable futures keep you up at night, and solutions that you foresee? One thing that like kind of concerned me is like at the intersection of cryptography and machine learning. Some people call it secure machine learning. Like, it doesn't seem like the crypto side is actually keeping up. A lot of the things like homomorphic encryption, secure multi-party computation aren't scalable enough. And so, like, for instance, like the CryptoNet paper from Microsoft in 2016, like you can encrypt the network itself and encrypt the data. It can train encrypted data and it'll spit out encrypted data, and then the user can decrypt it. But like what they're showing is like it took like 6 hours or something like that, or something like really dumb, to just train on MNIST, right? And so, and then things with like secure multi-party computation, the communication cost is kind of ridiculous. So I was wondering like what others thought in terms of like fundamentals and foreseeable futures and things that keep you up at night.
So one thought on the sort of issue where you'll have a research paper, their idea, you know, it takes tons of compute or it takes a long time. Consistently, if those applications are valuable, research can be done specifically to speed up, make more efficient, or re-represent the system for cryptography such that the training is fast, or you know, it will be able to be done with less compute or whatever. So those kinds of issues, it's interesting to watch that decline over time. For example, like in automating the search over deep learning models, there was this insanely expensive system that Google created, you know, using neural architecture search. Yes. Using
800 GPUs.
Yeah, that's right, that's right. Hundreds and hundreds, thousands of GPUs, spinning up entire skyscrapers of machines in order to train a single model. Super wasteful environmentally and energetically. It's this tragedy as far as some researchers are concerned. But then, you know, 4 months later, ENAS, efficient neural architecture search, comes out, and you can do everything at this point on one GPU in a couple of hours. And so there's this type of innovation which is in making things faster and more efficient that happens consistently. And so like, the kind of issue tends to not worry me as much as it not being possible.
Yeah, that seems a little bit more algorithmic though. Like I suppose my concern with the crypto is that like the fundamental math itself, like with matrix multiplications, right? Like it doesn't scale, and that's like pretty basic stuff, right? Like at the core of homomorphic encryption. So that's like my concern. Like the fundamental theory in those fields aren't scaling up because they're just not aware that they should, or maybe fundamentally they can't. What do others think about these particular things?
So I guess if I want to take a different perspective, so I guess what keeps me up at night is not necessarily for now the research question, but a lot about what will this skill be applied to and what kind of problems people will be focusing on. That's like, because I think if you look at kind of over the last, few years, at first it was a very like kind of happy picture of like machine intelligence, you know, would like have better healthcare, like self-driving cars are coming, and like it was kind of like, you know, very happy picture of that. And then you kind of see like over the last few years, this kind of view has become a bit more nuanced, and people have realized, oh, okay, like, I mean, there's even an article going as far as saying like, oh, there might be like a Cold War, you know, like linked to the development of like, yeah, I mean, that's kind of a very extreme view. And like, at first, like the people that were like kind of warning about the risk of like, the geopolitical risk around the development of AI sounded like a bit crazy. Like, what are these people talking about? And then you kind of see like the like military use case and like some of these use cases becoming more prominent, surveillance, things like that, and you're like, oh wow, okay, these people were not actually kidding. Like these and the things that because the technology developed really fast, and there's kind of an infrastructure in some countries to deploy it. You know, if you make your face recognition model better, well, there's a network of 200 million cameras in some countries where like your model can be developed, and then like it makes everything more efficient. So like that's kind of been like the how do we pick like what problem we solve? That's been kind of something that's been kind of bothering me a bit lately. And how do we make sure that like, you know, we can solve some of the like other big problems that a lot of people need to be paying attention to, i.e. climate change, things like that. So that's kind of more of that side that's been like bothering me, yeah.
Yeah, I want to second that, the part about surveillance. I think AI being used to sort of limit human freedom is something that keeps me up at night. The same tools that we use and we improve, you know, for other applications are very transferable to limit freedom. And yeah, that's definitely one of the top things, at least for the short-term uses of machine intelligence that scares me.
Yeah, and related to that, for me, I think one of the big things that concern me with AI is that today there's a big lack of awareness of people of like what could be done with the data. That's why there's only basically the whole movement of looking into the privacy implications of AI is not as big as I would hope it would be. I think a good example that I saw recently is Amazon Go stores, right? So what Amazon Go stores do is you just tap in with your cell phone, and then you can pick up any of the stuff that you like, and you don't need to go through a checkout line. You just leave the store, and then it would charge you for the items that you picked. One of the things that my friends and I noticed is that there's basically surveillance cameras everywhere in the store, and what they can do is basically learn the patterns of your shopping. They can see what items you picked up, what items you looked at. Maybe you spend some more time looking at specific products, and that could be used to later on target you with ads or basically learn some private information about you. And today it's really hard to realize that because these things have not become as big.
Yeah, actually, so Amazon, the sponsor earlier, my friend Daniel Ron, he's actually working on Amazon Go Store version 2. So maybe, you know, you should talk to him about that.
I also think about to what extent are these machine learning algorithms tested well enough before they're deployed in real society? If you think about the extensive process that people test drugs in pharmaceutical companies that have the FDA guidelines before they release them out to the public, I wonder if AI applications are moving so fast that policies, regulations, and just the culture can keep up with these technologies. For example, I just with the Tesla's autopilot mode, definitely there are some aspects where it makes driving safer, but there are other aspects that are are still very untested. Well, I guess it's an open question of where you get the data. So you might have to actually do some real-world driving to actually get the data. But I also think that to be able to put people's lives on the line when an algorithm itself is not completely robust seems very risky to me. If you saw one of the talks today by Jessie, she was talking about adversarial attacks on neural networks. And the fact that you can attack image classifiers so easily is really worrying to me, because we are deploying these image classifiers out in the real world with self-driving cars. And the fact that, yeah, especially since they can be broken so easily, it makes me wonder to what extent we're rigorous enough in testing our own algorithms before we actually test them in the real world. And this is kind of clouded by the fact that in research, especially in machine learning, there's been a lot of hype in the recent years. And so every single time a new algorithm with cool results comes out, everyone wants to jump on it. So deep reinforcement learning, which is a field that I work on, has been pretty hot in recent years. But most of these algorithms that have been developed in the last 2 years are very brittle. And you don't really see that in the papers, but when you work on them, you realize, oh yeah, maybe they just actually got lucky with the hyperparameters, or they got lucky with the random seed. And I think people probably need to be more wary of these nuances in the algorithms before they deploy them in society.
Can I build off that? Like, I think that's something that I find really worrying. Like, people put so much trust in like some research that comes out, but not realizing like where the gaps are or the holes in the algorithms or how they can be broken. And I think there's like a disconnect between like the research that's being done and then how it's going to be used in the real world. Like, this is at the end. Well, I think there is a large group of researchers that want their work to be applied to meaningful human problems. But I don't know if people are really thinking through the steps to make that happen. I think something though that really keeps me up at night is like there are problems, for instance, like autonomous weapons and like really scary technology that could be made pretty easily today. And I think there's a lot of debate about like whether companies or certain people should work on these problems, but I think we have to realize, like, as humans, there's going to be people who are working on it or are trying to build things no matter what. Like, the tools are free. And I think we have to think about, like, even if we don't want to, are there some things that we should still explore, like, as protections? And I think grappling with that fine line between your ethics but also protecting other people and yourself.
Yeah, it's kind of scary because all the hype and the amount of money that's going into it, the incentive is like, all right, if we don't do it, like another company will do it. So like, Google with the Pentagon and, what Microsoft is doing right now. Or even like Google trying to get back into China just to get more data. The hype is kind of, and also the incentive with the amount of data is just kind of crazy. And any other thoughts on?
I want to second the autonomous weapons use case. So I guess as at Google, when Project Maven was, publicized, and many of my coworkers sort of changed their profile pictures to cancel Maven, everyone was reacting to the sense that we were going to help the U.S. military create autonomous weapons which would be able to efficiently kill huge numbers of people. And the fact that Google, dropped out of that particular race is uninteresting when you realize that the research frontier is open, the papers are published openly, the software is open source, like that is TensorFlow and PyTorch and every framework that researchers are using to create these tools. We give almost everyone in the world immediate access to bleeding edge machine learning technology, and it's unlikely to change in the near future. So if, there are entrepreneurial, people who want to, say, set up towers and use computer vision to shoot anybody of a particular type or who's doing a particular thing and wants to train classifiers to that effect. It's very practical and easy. And as we continue to develop these tools, it will just get more and more trivial to set these things up. So I share your worry.
Yeah. So just adding on top of everything, one other thing that worries me is that in a lot of countries, people who make the policies don't really understand what everything is about. Take a very a developing country or a third world country, for example, and I can bet that the ministers there, some of them even don't understand what the internet is about. And some even believe that the internet can be turned off with a switch, things like that. So like when these people talk about
Not just
like,
in developing countries.
yeah, so, well, anyhow, so then, so when these people, when these large corporations train data or collect data from the people of these countries, they often don't know even if their data is being misused or targeted, and they don't even have any like legal infrastructure to fall back on, or like to fight cases with, just because they're in a country where they don't understand what privacy entails. The legislators don't understand anything. So there's also like a lot of people in the rest of the world that companies can exploit. And that worries me a lot. And just in general, like, you know, and I think like school curriculums now should have, should teach about like what these privacy implications are, and what are like, when you think about a solution, how to evaluate it, so that people in general have an idea of like, okay, they can tell, well, okay, is this safe or is this not? And there should be like a general push from the people to encourage governments or any policymakers to push for like this sort of efforts.
I think to add on to that, what Bristy was saying about like having policymakers who are like, fluent in machine learning or like these technologies, like I think what I noticed in a lot of peers, and like I mean I was guilty of this too, is just like you want to separate your work in research and like what you do in your companies. That's like very ideal. You're looking to the future, like an ideal future. And you don't want to get into the politics. You don't want to get into the social issues that like, or you don't want to think about. You don't need to think now about like a robot taking over the world or things like that. But I do wish that more of us were more proactive and more engaged and involved in these issues, like actively and proactively. And I think the earlier that happens, the better. Yeah, and I think that would hopefully curb some of these problems that we're all discussing.
Yeah, I guess like kind of to summarize, there's kind of a tension between how fast, because if you think about like what are really some of the bottlenecks of progress in these areas? Well, the bottlenecks, I mean, there aren't that many, because like people have ideas, they can implement them. Well, that's not that easy, but they would implement them and publish. So like there is actually no friction on that side, right? So like that's why this field has been progressing so fast, and the more people have been added, the faster the progress has been, because, but on the other side, like there are kind of real bottlenecks in terms of how quickly the political and policy system evolved to this change. And when you look at how fast, a lot of these things have been happening relative to like where in the like mindset or where in the agenda some of these things are for the decision responsible for public good, like they haven't caught up, and you kind of end up in that weird thing where there's like a gap between like, what discussions are in the research and entrepreneurship communities, and the discussion in the political circle. And historically, these communities haven't kind of mixed well at all. So like, so it gets into this really tricky setup. Yeah.
Can I just add another thing? It's a bit unrelated, but there's another thing that keeps me up at night, which is that I think with a lot of the popularity of AI these days, I'm starting to get the feeling that there's a notion that AI is the same thing as deep learning, which is the same thing as machine learning, and that's not true. In fact, the quest to kind of develop an intelligence that's not human has gone back for a long time. In the 30s, you had Norbert Wiener, who was a professor here, Warren, McCulloch and Pitts, who are trying to work on cybernetics, which was the early versions of neural networks. And back then, computer science wasn't even a field. And if you actually look at how computer science as a field has evolved, like you can interpret it as like computer science was kind of invented to solve AI, right? Because if you think about the early computer science problems, how do I make compilers? Well, compilers originated from the desire to figure out how to make code write more code, right? That's an AI problem. How do I make a program write itself? Search algorithms that you guys learned in 6006, 6046, search is also a fundamental AI problem. When we think about data structures, well, data structures were developed in order to make search algorithms faster. So a lot of the important issues in computer science were actually developed to solve key problems in intelligence about how to represent intelligence in math and execute it in code. I think that with with the popularity of AI these days, we kind of forget the history of how all of this happened. And I think when we forget the history, it also kind of keeps us very nearsighted in terms of how we can develop AI further, as well as learn about the issues that people faced back in the day.
Cool, yeah. So I'm just going to switch gears a little bit. And so one question I have that I hope would help some people who are reviewing this or in the audience would be, if you want to become more advanced in machine learning, what are the best habits to develop? A lot of you seem to have like particular habits. I know Jeremy keeps like 1 million journals. And so what do you all do?
I can start. So at some point in, I think maybe sophomore year, there was a New York Times article, I think by Andrew Ng, that where he mentioned, think about the sort of compounding rate if you just read one paper a week or something like that, paraphrased. But that's something that really struck me, and I gave that a try, and I think just, spend a week on it, try to really understand that paper, and just do that week after week after week. And I think just, 3 months, that has a pretty big effect. So that's something I'd recommend. And, the choice of papers, I think there are so many resources available online, blog posts, all of that, discussions. So it is important to kind of start, maybe not with the most advanced paper and go from there, but starting with some of the fundamental papers in whatever space you might be interested in, and kind of just do this week after week after week, and within a couple of months, I think you that has a very big effect. Yeah.
Well, yeah, that's kind of interesting because when students are asking me how to get more into machine learning, how to learn more advanced concepts, I literally say the same thing. I'm just like, I read a ton of papers all the time. That's all I do. I don't do anything else. It's not like there's some magic formula or anything. And so, but students seem really averse to that because they're like, oh, it's a paper. Oh, geez, I don't want to do more work. And so there seems to be this weird barrier, which is where I hope MIC could come in and help kind of ease that curve. But I mean, perhaps there are other ways that could convince students that reading papers and going to like talks at CBMM or whatever would be a good idea.
So I guess to complement on that, so and I would love to also hear you from other people, but I guess the way I got really pulled into this was more like there were a few projects I had in mind that I wanted to work on, and the paper were a means to understand that. Because of course now with there are so many papers published that you cannot just go on a random search and find. So maybe you want to have one of my original project in junior year IAP was there was this competition to answer 8th grade science reasoning question, and I did that with a friend. And we wanted to really, how would you approach some problem like that? And we kept reading about question answering and, summarizing documents and things like that. And that was kind of really good to have a goal. And then the paper was just kind of on the way. Because the goal is kind of what pulls you, and then the paper is what prevents you from working on that. So when you have something that pulls you like that, it's okay, I'll read the various literature that will help to answer this question. And kind of similarly with some of the new projects we want to do at Sela, where we want to kind of use computer vision for satellite imagery to detect oil pollution. That's something I would, for example, start reading upon, because now there's a goal, and the paper is just kind of a mean to a goal. And that's kind of how I think about this. Basically have some problem you're passionate about, and you can either have some of these big problem you want to solve, or some of the even side project. You think, oh, okay, I want to create a model that would take a name and recognize which country it's from, or which culture it's from, or have a softmax over which country it's from. And it's okay, how would I approach this problem? How would I solve this? And having some of these projects as well can help you with like, because of that you would learn, okay, how RNN and like LSTMs work and like things like that, right? So that's kind of how I think about it. And you also learn the limitations, which is kind of very important. Yeah.
Huge.
Sorry.
I'm a huge fan of this project-based learning. If what you're interested in is applications, it's actually extremely useful. It's extremely useful. I wanted to make a comment if you're interested in developing novel algorithms that implement ideas that haven't been implemented before, which is that if you want a grounded understanding of algorithms, it can be very useful to actually implement every major machine learning algorithm. That is like starting with linear and logistic regression and k-nearest neighbors, but progressing to feed-forward neural networks, convolutional neural networks, and recurrent neural networks. And that is like implementing it from scratch, not just using a TensorFlow high-level API call to somebody else's code whose code you don't understand. Because that low-level representation will let you change things at will, and you can watch what the impacts of your changes are on the way that your system works. And you'll have a very low-level representation, which you can compare to reality. So when you read a paper and you've implemented that algorithm before, you know exactly which parts of the algorithm they're talking about and how you can implement it yourself because you have your own system.
One tip that is like less on, I guess, like how to build the skills is, which I found like super important, is talking to people. So I think acknowledging that this is a very like exponentially fastly growing field and things can be very overwhelming at times. I think it's extremely important to build a community like this one and just exchange ideas and be comfortable knowing that there's no way that you're going to be able to keep up with everything going on in this field. And I guess like involving other people from various different backgrounds to help you navigate, I guess like the state of the art in this field and like what research is going on and keeping an open mind in that sense. So I think that like talking to people is very important.
I wanted to add on top of that, in my personal experience, before joining MIC, before joining the machine learning paper group, I've always been interested in machine learning. I've heard some cool terms like LSTMs. I've heard things about recurrent neural networks, but I've never really known what they do. So what I did is I downloaded the papers, I put them in my laptop, and I thought I'm going to read them. Like a few years go by, I never opened them, never find any inspiration to do that. And for me, I think the changing moment was when I joined the group. When I got surrounded by these really smart people who actually sit down, go through the paper, make everyone else do it, is what actually gave me a push to start. I think for a lot of people who might have similar experience, I think getting in the right environment is a good way to start.
Yeah, I would, like second or third, talking to people. Like I think when I was doing research, just sort of by myself at MIT with some people, it was easy to fool myself to think that I like sort of understood things. But it wasn't until coming to a place like Brain where I was talking to people for the first time and like maybe re-implementing a few things where suddenly I realized that I didn't really know anything, that I sort of had all these lapses in my understanding and like I learned to really fall on people or to trust people that like you talk to these people about these algorithms and they really fill you in. Like it's really, really useful to talk to people who have been in the field for longer than you, who know more, and just having weekly reading groups at places like this is super, super helpful. One recent thing I started doing, which might be helpful, is one of the most frustrating things to me is, let's say I read a paper like a year ago and then someone comes up to me and they're like, oh, have you read this paper? Like, what do you think about this? One of the most frustrating things is I'll be like, yeah, I read that paper, but then I'll remember nothing about the paper. I'll be like, oh, what experiments did you run or something, or what did they actually talk about? And I'll be like, I have no idea. So I started making flashcards of various things. There's a program called Anki, A-N-K-I, and it's all about like spaced repetition and stuff like that. And I think it's quite good. It's just literally just flashcards, and you can just write stuff down. And I find that it's a lot. You just don't forget things as easily, which I think is pretty important.
So one question: what kind of things do you put on your flashcards?
What?
What kind of things do you put on your flashcards?
For instance, there's this textbook in reinforcement learning called Reinforcement Learning, and I was just reading through it again, and I realized there's this thing called value iteration, which is a certain algorithm. And I heard about this a while ago, but when I read it again, I was like, wait, what exactly is value iteration versus policy iteration? How exactly are they different? And I could maybe hand wave some details around, but I sort of forgot the exact details. And I read the thing again, and I was like, this is exactly what it is. So I wrote it down on a flashcard. I said, this is what value iteration is. This is what policy iteration is. This is why this is slow. And it could be from things like that, and it could also just be like little linear algebra tricks, little statistics things, like what is this property of the trace of a matrix or stuff like that. And it's been pretty good. So it feels like I'm back in school, but I think treating this all as sort of a learning thing, like being a lifelong learner is something is pretty important to me, and so I don't mind it too much. And it's fun being able to remember things. So.
Surya is underselling Anki. It is a spaced repetition system in that it is optimized for giving you the information you need right before you are about to forget it. And if you use it consistently, you actually see really, really dramatic improvements to your memory on the things you're trying to remember. So I want to second that.
Yeah, it's really good.
But, yeah, also on that point about community, yeah, I think that was also something that really helped me learn machine learning a lot better, a lot faster actually. I would actually try to skip class so that way I can go to the MIT paper discussions. Grad school is just mainly me just doing research and going to those discussions. And so that was actually really fun. And that actually wouldn't have happened, so I wanted to tell a story earlier, but I forgot. Was when I first started to get into machine learning, I went to the Cambridge AI meetup group, which is where I met Surya and Jeremy. Surya was sitting right next to my right, and then Jeremy was sitting next to him. And we're like discussing about like, what's the best time to go to have these meetings because no one was really showing up. And Jeremy was like, well, clearly we're all here on Tuesday night, so this works. And then Alex, the guy who was running it, was like, oh, well, does Thursday night work? And Surya was like, oh, well, we have this MIT thing on Thursday nights. So afterwards, I asked Surya, like, oh, can I attend this thing? Here's my email. And he never emailed me. So this may not have happened at all. This conference might not have happened. But I think it's because I accidentally may have coughed on his pizza that night because I was really sick. So I don't know if he was mad, but I stalked Jeremy online, found his email, and then I was like, hey, this is me from the reading group. Where's this other thing? And then so I went to the room, and Shram and Ali were at the top of the classroom drawing neural networks on the board, and this is the first time I've ever seen MIT students in a classroom, so I was like, oh, okay, this is how they interact, interesting. And then Shram came up to me afterwards, and he's like, hey, are you here for the paper discussion? I'm like, yeah. And I was eyeing the food the whole time, and he's like, hey, you want some? I was like, oh, yeah. And I just kept on coming back for the food. But yeah, and then they invited me to do papers presentation, so, and then that's how BMIC started. Yeah.
I also wanted to build off of that, which I think the MIC is a really great community for people to teach each other concepts in machine intelligence. I think for me, I realized that one of the best ways that I learn is to teach other people. And I think Richard Feynman also said something like, if you can't explain something simply to someone, then you don't truly understand it. So I think to echo what Shraman, Hassan, Jeremy, and Sims were talking about talking to others, I think that's extremely valuable. Hassan also mentioned that, well, if you're driven by a very high level interest and goal, then naturally you'll be able to figure out the steps to achieve that goal. And so that goal is your motivation. But then the question is, how do you find your high level goal? How do you find your motivation? How do you find what you're interested in? And so I think it's very different for everyone. But for me, things that have helped me is I try to keep a journal of all my thoughts about anything. And when you write everything down, that forces you to think about, reflect upon your own life. And when you connect different aspects of your life together, you start to see different ways that things connect. So I can say, oh yeah, things in research connect to this conversation that I had with another friend, which connects to some other aspect other conversation I had with my family. And then I think for me at least, the more connections I make, the more beautiful this web of connections is. And for me, I'm inspired by this beauty. And I think for many people, that's the like making connections is what creates this aha moment that makes people motivated about, wow, this is so cool. Let me go learn more about this. So I would recommend writing a lot in a journal.
Actually, to add on that, I mean, it's not directly related, but I actually have something similar. I've had it for 4 years now, and it runs for 1,000 pages. I have it my quotes of the day.
Wow, that's
more like thoughts of
fantastic.
the day. So, yeah, nobody will access it.
Yeah, so the last set of questions are, how do you think that machine intelligence will or could change traditional computer science curriculum? And then I guess also tack on, how valuable is grad school for machine intelligence research and engineering? A lot of you actually don't have your graduate degree, and incredibly impressive, so maybe you could distill some advice.
So I can answer the grad school question. This is my second year in PhD. I think grad school is very valuable for getting a more rich and deeper understanding about the philosophy, concepts, and algorithms, approaches to machine intelligence as a field. I think when I was an undergrad, I was part of a great community of people who all were interested in this, but kind of like Surya, I also felt like I didn't completely understand everything. I knew sort of the concepts, but I didn't really understand things extremely deeply. And I think grad school forces you to be very honest about what you actually know, because this is the time. So I kind of think about grad school as like you against the entire world for all of time, right? Because when you produce research, you're actually trying to contribute to something that to the body of knowledge in the entire world that has accumulated since the beginning of when people started to do research, and that's a very big, that's a tall order, and as a result, you at that point you're not really a student anymore. You're producing new knowledge, and I think that change in environment forces a student like me to have to be very honest about what I do understand, what I don't understand. And the more I realize that, the more I think about how little I actually know. The analogy that I use is that during high school and undergrad, I'm like a little log floating down this river stream from a mountain. And then once I hit grad school, I reach the ocean. And like my momentum just stops because the ocean's so big. So that's, I think, really exciting, because you have the entire ocean to explore, but at the same time, it's also a lot of you kind of have to create your own current at that point. And I think that's also very good for personal development too. I think like because you have a lot of independence in grad school, you kind of I think of grad school as like practice life, because in grad school you have to develop good social skills, good presentation skills, good communication skills, good problem solving skills, all in a very small period of time. And you get to do this in the freedom of this big ocean.
Yeah, I agree. But I work at DeepMind, and I think like 6 years ago, I think there was no way I would have thought that I could do research like this without a PhD. Like, I think that thought never even crossed my mind, really. It didn't make sense. Like, but with the demand, and maybe demand is really just hype, with sort of this interest in machine learning and like all this money being put into it, I'd say that there's some sorts of research that are really well done in industry. Like, I would say a lot of deep learning research is done really well at places like DeepMind and Brain and OpenAI and stuff like that. I would say maybe things like deep reinforcement learning are really good in industry. But I would maybe counter, and I don't want to like go and disagree, but I would say that like places like this are also really, really good for growth. You are surrounded by brilliant people everywhere you look. And these people are just as interested in you, in advancing their own knowledge, in advancing AI. And it could be a really, really good environment to learn. Like, I've learned a lot from being in these places, and I find that grad school does seem very much like you against the world. But at least here, it seems like you're all sort of in this together, and you all sort of help each other out. And whether it's things like TensorFlow questions, which I always have, or you know, how do you deploy these jobs at scale? Like, there are always people there to answer it. And like I was saying earlier, there's so many people to lean on too. Like, you have all these people working on all sorts of machine learning, and you know you don't have to read all these papers anymore. You can just talk to people and see what they think is really good. But yeah, I think it's, if you can find a way, if this sort of research interests you, then I think places like this are quite good to learn a lot, to do research. That might have just been a pitch for DeepMind, I don't know, but yeah.
Yes. One more thing I'd like to add is, like, I also interned at DeepMind this summer, and the sheer amount of resources that like DeepMind or Google or FAIR possesses, it's very easy to like do experiments quickly or like to get results quickly, just because you just have a lot of resources at your disposal. And yes, there is the compute, but there is also like this huge amount of like talented people who have worked in industry and who like know what works and who doesn't, and they might be able to prevent you from going down the rabbit hole into something like unsuccessful. So I actually talked with someone who did a PhD here at Media Lab, and she has the same feeling that, you know, you can do stuff a lot quickly just because the infrastructure and everything is designed in such a way that helps you to do like things very quickly without any trouble. So there is that. And one question I had for myself was if I'd be able to do research if I joined DeepMind or Google without like a PhD, because it seems like, why should, like, when there are so many PhD students out there who are like, who know much more than me, why would they let me do research anyways? And a couple of feedback I got from there is like, you can transition from a research software engineer to a research engineer, and then from a research engineer to like a research scientist. And also now there are some companies which are thinking of like combined PhD programs with universities. So just like that might be a good option for people. So your faculty works as in the same company, advises you for like half a year or something, and then you work in the company, do your usual research and publish papers. So yeah, so it's like now there are so many different options to choose from, which is really exciting and nice, because you're not like limited. If you really want to do like machine learning in an industrial setting and solve like real world problems, then it also means that you no longer have to like get a PhD degree just for the sake of like getting an interview or a job at this sort of places.
Yeah, I wanted to add a perspective to that, which is if, so I work at a startup, and the main focus here is trying to solve a very specific vertical, where, you know, 3 years ago, that vertical couldn't have been solved. Specifically, you know, object detection is a computer vision task, which in 2014, you know, the state of the art took about 14 to 20 seconds at inference time for an image, and 2016, 20 milliseconds at inference time, right? So seeing that sort of, that's just one example of a task, but there are so many different tasks like that in machine intelligence where, you know, you can build a product that can solve problems. And so I think to kind of go to your original question of, is grad school worth it? I think you have to sort of think about what sorts of, I mean, there's so many directions you can go with machine intelligence. Are you interested in like the really open-ended work where, you know, you talk about agents and it's really sort of application agnostic, and perhaps, you know, some things are very compute, it require a lot of compute, and some things don't. I think there are all sorts of problems. I think CBMM here is working on some really, really exciting research problems that don't necessarily even require a lot of compute. At the same time, you know, there's machine intelligence research, because it's growing so quickly, more than ever before. We've been, you know, we can solve problems now, build products that capture a particular vertical, and if that's what you're interested in, I don't think grad school is, you know, a requirement for most cases. I think turns out like a lot of this is engineering. It's research engineering, so there is an aspect of being able to know, the papers and kind of the state of the art. But I think not only can you sort of build things and solve verticals with engineering and a bit of research, without a PhD necessarily, I think you can actually innovate there. So as an example, at Synapse, we have folks with masters, and we don't have anyone with a PhD right now on the computer vision team, but we've worked on state of the art. We've built on top of that. We're submitting a paper to CVPR. We have some patents granted on semi-supervised learning, things like that. So there's definitely innovation still going on. So I would say it's not especially in vertical AI startups, I don't think it's a big barrier to have a PhD or not have a PhD.
Yeah, I guess my perspective on that is, so I'm on the startup camp as well. It again goes back to your motivation. And I guess another framework you can think about is kind of competitive advantage. So think about what is the competitive advantage that you have in, say, grad school versus in other places, which means that what is something that you can do where it's maybe better to do in grad school than in other places. So in a sense of, for example, I feel like in some case, if you want to compete with on research that requires a lot of compute power, it's gonna be hard, right? Because you pit as one grad student working with 4 colleagues against Google teams, right? So you kind of have to pick the kind of problems where being in grad school is actually an advantage, and that's kind of what would be my perspective on that. Otherwise, it's definitely true that there has been a really big blur and a gradient in terms of the product and research separation, because back when we started as freshmen, it was very clear. It's grad school, and then you have engineering work. And then there's been this residency program which have started. There are many of them that kind of combine. You have startup publishing papers. You have you have grad students working on applied research project that drop out. It's becoming kind of a chaos and a spectrum. And I think it's positive, because then you kind of find your own niche. If you want to do the math of deep learning in a math department, maybe that's good for you, and you can do that. But if you also want to do other things, you can kind of find your own niche that correspond to what suits you and what kind of setting motivates you. So that's kind of I guess my perspective on that. So yeah.
So I work at Brain, but one upside to graduate school is that this conflation that Michael describes between our AI and machine learning is, and deep learning, is in part coming out of the fact that deep learning can let you create useful products in the immediate future. But if you want to go beyond deep learning, you probably want to be in an environment where everybody is not thinking the exact same thoughts about what is worth doing and why. And so graduate school presents you a much more diverse range of perspectives on the future of artificial intelligence. And one easy example is that gradient boosting is extraordinarily useful for almost every task that is not compositional, that it's not a vision task, it's not an audio task, it's not a language task. If you have business data, using random forests or gradient boosters is still state of the art. And so there's this sense that there are space of algorithms that usually look at different kinds of structure that are developed in places that are not these elite deep learning labs. And so if you're interested in that sort of more diverse and grounded perspective, it might be worth going to graduate school.
Going on, I think your first question on how is machine intelligence changing curriculum, I think something I noticed with MIC is, and what a lot of people are echoing, that you don't need a PhD to do the work. I think there are people that are in high school that can do the work that certain PhDs are doing. I would say there's some things that younger people can do. It's very accessible, and I think what I notice is people are self-organizing and learning on their own more, learning in communities. And I think something I've noticed is there's more communities abroad that want this kind of access. So I was just at a place called African Leadership University and like trying to help them form a machine learning community. And what's difficult there is that you don't have access to things like you do at MIT, like labs where you can just plug into a lab and start researching, or professors or companies around you doing really amazing things, or classmates like interning or doing amazing work. And without that access, like how can you still learn and get to the same level as everyone else in the world? And all the tools are online. There's like lectures, papers, everything. But I think in machine learning, what I've noticed is that there's been a lot of like community organizing and I think innovation in how we're educating ourselves in machine learning that I think we need to continue like spreading around the world so more people can join the conversation. And I think MIC is a really great platform for that. But I think there's more work to be done.
Cool, yeah. So that's really all the questions, and if anyone wanted to ask questions, we actually have like an intermission between the programs, so for half an hour, if anyone wants, just pass the mic. No?
I have a question. This is like such a great group working on all sorts of different forms of machine intelligence and software engineering. So this is a problem that I've been thinking about, and I'm not sure if I have good conclusions to. But going back to, I think someone here mentioned sort of Project Maven, but not that in particular. This idea that the tools that we're developing at sort of almost an exponential pace here can be misused, and particularly misused for security and sort of military and defense applications. So one perspective to that, and from a lot of folks at Google as well, is let's just not work on that, because drones that can target people, that's clearly very bad. But one thing I worry about is, Jeremy mentioned this earlier, it's just the open source nature of this field means that all the papers are out there, all the tools are open source, they're out there, TensorFlow, PyTorch, etc. And what if one of our enemies or some other adversary just builds this and we aren't putting our effort into military and defense? I think at least America, we have certain values that we really pride and values around freedom, around democracy, and I think it's very important to me at least that we protect these values. Not everyone in the world shares those values, and so I'm very conflicted when I hear my friends at Google or just in the Valley, they're very, very against using, building applications of AI in military and defense. I'm very conflicted with, whether we should just not be putting our efforts there, or whether we should be doubling down our efforts there, because we still want to, we have values that we want to protect. So I'm curious to hear thoughts on the panel here.
So one current thought is that as our technology becomes more powerful, we will spread the tools that are capable of doing extraordinary amounts of damage to us and our civilization, with like nuclear weapons being the obvious example of something that could have ended human civilization, and this sort of continuation down the path of more and more powerful technology in the hands of humans who are still, happy to go to war to defend things like freedom are. Well, I don't know, there's this extrapolation that you do and you wonder, am I contributing to a system that is likely to do extraordinary damage to everything that I value and care about? At a personal level, people don't want to think that the code that they're writing is going to be used to do things that are against their moral system. They don't want to be associated with an arms company. And so there's some, who am I and what am I doing and what is it doing in the world in their mind. And they tend not to have this sense that, it's worth having these systems because, in part, we just fought 2 wars in places that people thought it wasn't worth our military being. And it's somewhat rare to hear defenses of military improvement because we're not going to war with countries that we think are fundamentally opposed to us ideologically. It'd be better to live in this world where everybody cooperates with one another, we trade with each other. Large-scale wars between major powers should be avoided at all costs, and certainly contributing to technology that would be used in that feels bad to them. But I appreciate your perspective. It's also surprising, so I guess there was this summit trying to stop the use of autonomous weapons where countries would come together and ideally agree on some set of policies. And the Chinese were actually much more heavily in support of bans on autonomous weaponry than the NATO countries, and I guess that surprised me. So.
Cool. Yeah, so I guess we're slowly over time, and if everyone wants to get lunch now, that'd be cool.
Thank you so much for the panel.
Thanks.